Welcome everyone on the next learning session during this sunny Friday, at least sunny Friday at my city. My name is Daniel Bigos, and today we will try to demystify trustless bridges in the Polkadot ecosystem. The purpose of the session is to share knowledge about the Kusama to Polkadot bridge, that later anyone who will know how to use that bridge and anyone will know how to build any other trustless bridge in the Polkadot ecosystem. Let's talk about the agenda now. So at first I'm going to provide some introduction and terminology. Then we will talk about light clients and finality. Then we will check the message flow in the bridge. Then we will have a quick demo about asset transfer between Kusama and Polkadot. Then we will have some code walkthrough, and then if we will have some time, there will be Q&A session. So introduction and terminology at first. XCM. So XCM is a cross-consensus message format, and it is a messaging format and language built to enable communication between consensus systems. It is a generic and common format, which means that it is not specific to the Polkadot ecosystem. Having introduced XCM, I need to talk also about XCMP, which stands for cross-chain message passing, and it is a transport layer for XCM messages. So XCM messages are sent over the XCMP. Having introduced XCM stuff, we need to talk about multi-location, crucial part of the bridges solution that is connected also to XCM. So multi-location is an abstract idea used for identifying any single entity within the world of consensus systems. So multi-location identifies any single location, like a parachain, like a smart contract, like an account, like a pallet deployed within Substrate runtime, anything. Multi-location is defined with attributes like parents and interior, and multi-location is expressed as a relative location to the current location. And let's take that example. So we have two dots slash, which means that we need to exit our current location and go to the broader one. Then within that broader one, we need to go to the parachain 2, and within the parachain 2, we need to go to the account 2. That was just an example multi-location. Blockchain bridge. Before talking about what blockchain bridge is, let's think at first about a translator. So a translator is a tool, is a mechanism that allows communication between two parties speaking different languages. And the same we can say about blockchain bridge. So it's a tool, it's a mechanism that allows communication between two sovereign chains that mostly have different consensus systems. Blockchain bridge allows to send assets and other messages between those two sovereign chains. And the question is, why do we need bridges? So, for example, we want to use some external dApps or other mechanism, like imagine a situation that we have some assets on our chain, but we want to swap that assets on a DEX that exist on totally different sovereign chains, sovereign consensus system. And to use that DEX, we need to bridge our assets to that blockchain, to that consensus system. The second option is that maybe we want to leverage some benefits of the different chains, like for example, lower transaction costs or stuff like that. Trustless bridge. So trustless bridge is a specific type of a blockchain bridge in which there is no point of centralization. In other words, it means that there is no single entity that runs the bridge, that take the administrative part of the bridge, that guarantees security of that bridge. In trustless bridge, we trust in protocol, cryptography, and code. the whole security is provided by the protocol, cryptography, and code. It means that we have the whole security checks done on-chain. We have on-chain message verification. Having said that, we can claim that Trustless bridge has the same security level as the underlying blockchains, because as far as those blockchains are secure, the bridge is secure itself. And today, during that session, we will talk about Kusama to Polkadot bridge that is being developed by Parity. Bridge Hub is a system parachain, and it is a hub responsible, as the name suggests, for bridge operations. So Bridge Hub handles inbound messages, verifies them, and then trigger their dispatch. And also, Bridge Hub prepares messages to be sent to external sovereign chains. I need to mention that a Bridge Hub can handle multiple bridges at once. So on a single Bridge Hub, we can have a Kusama to Polkadot bridge, we can have Ethereum to Polkadot bridge, and we can have any other bridge that comes to your mind. Message lane, another term connected to bridges. So message lane is unidirectional communication channel between apps or chains. So message lane is identified with a 4 bytes identifier, and message lane treats messages just like byte arrays. Within a message lane, each message has unique identifier, and that identifiers are used to identify messages and to deliver that messages in a proper order. We can have many lanes, many message lanes within a single bridge, and a message lane is defined and set by the runtime developers. Runtime developers can set many rules for the message lane, but we will talk about it later. Relayer. Relayer is an entity that watches and relays messages between sovereign blockchains. We need relayers because blockchains are not able to communicate with each other. They don't have any built-in mechanism that allow communication with sovereign chains with different consensus systems. We need something to allow communication between them. And a relayer can be anything. It can be a software, it can be a person, it can be any script, it can be anything. Having said that, we can say that relayer is an off-chain mechanism that is untrusted, but we don't need to care about it because the whole security is provided by the on-chain verification that I said previously. And in the case of the Kusama to Polkadot bridge, relayer, besides relaying messages, relayer sends also finality proofs, but about finality, we will talk later during the presentation. Foreign assets palette. Foreign asset palette is a dedicated palette for the asset hub, and it is nothing else but the second instance of the palette asset within the asset hub runtime. Foreign asset palette, as the name suggests, is responsible for managing foreign assets. Those assets can be bridge assets, so assets from external consensus system, and also assets from the same consensus system like Kusama or Polkadot, but from other chains. In foreign assets palette, we have some differences in configuration in comparison to regular asset palette. So in foreign asset palette, we use multi-location as an asset ID. So each foreign asset directly points to the original asset that exists on the original chain. The second difference in the configuration is that asset creation, foreign asset creation, is allowed only by XCM calls and some on-chain governance mechanism. Bridge message palette, another crucial palette in terms of the Kusama to Polkadot bridge. So bridge message palette is responsible for both incoming part and outcoming part. So for outcoming part, it queues messages at the source chain. It prepares messages to be sent via the specific lane to the destination chain. Once we talk about destination chain, we use bridge palette for receiving incoming messages, for triggering verification of those messages, and then trying to dispatch them or forward them. And within that palette, we have three important extrinsics. The first one, send message, is used by other runtime palettes and other stuff to send messages over the bridge. So other runtime entities, palettes, use that extrinsic as an entry point for sending message over the bridge. We also have extrinsic receive messages proof. And we call that extrinsic if we have a bridge message palette on the destination chain. So the relayer calls that extrinsic to submit a transaction containing the bridged message or any other stuff. We also have receive messages delivery proof extrinsic that can be called by the relayer on the source chain. And that extrinsic tells the palette that, that our messages have been exported to the destination chain, and now we can set those messages from the outbound lane at the source chain to we can set them as delivered, and also we can pay the reward to the relayer for relaying our messages. Now let's talk about the flow. So with the bridge message palette, so at first some palette just submit an extrinsic to the source chain and tells the source chain to send a message. While that extrinsic is executed on the source chain, we have a message put into the outbound message lane. Then the relayer sees that a message is in that lane and sends the message to the destination chain with the receive messages proof. Then the message gets verified, dispatched, forwarded, anything. And once the message is delivered, relayer can confirm to the source chain that the message has been delivered and proceeded on the destination chain and can claim rewards. Payments. So from the user perspective, the whole transaction fees for using the bridge will be paid once on the source chain. But the whole payments mechanism is still under development. There are some still ongoing talks. So about payments, we will talk in the future when something will be clarified. Light clients and finality. So for playing with finality, for playing with on-chain message verification, we have many palettes. And the first palette that we use is bridge grandpa palette. And that palette can be treated as a light client for the source relay chain headers. So for example, in our bridge, Kusama to Polkadot bridge, when Polkadot ecosystem is our destination ecosystem, on the Polkadot side, we need to verify headers of the Kusama relay chain. And that is, the destination of that palette. That is what the palette is used for. In that palette, we don't need to import all headers, only some of them. On the destination chain, in Kusama to Polkadot bridge, we also need, on the destination bridge hub, we also need to have a light client for a parachain, and that light client for a parachain is bridge parachains palette. So we use that palette to verify if parachain headers, in that case, headers of the Kusama bridge hub, are finalized within the Kusama relay chain. Now let's talk how the whole message verification, once the message is relayed by the relayer from Kusama to the Polkadot, how does the message verification works? So the message verification is done on the destination bridge hub, on the bridge hub on Kusama, when we talk about sending some stuff from Kusama to Polkadot. And on that Polkadot bridge hub, we need to check if Kusama relay chain headers are finalized. We also need to check if bridge hub headers are finalized within the relay chain. And also we need to check if the message that was relayed by the relayer, a message from source bridge hub, from Kusama bridge hub, is stored in the storage of the Kusama bridge hub. And all of that, everything is sent in a trusted way by the relayer. So we trust only in cryptography and the code. Now let's talk about the message flow between Kusama and Polkadot. Let's take as an example, as a use case, the demo provided by the Core Bridges team. This is the QR code with the link to the Polkadot forum. And in that forum post, Core Bridges team put some instruction how to play with Kusama to Polkadot bridge. The bridge for now exists on Rokoko to Wokoko. Rokoko is mirroring Kusama, Wokoko is mirroring Polkadot. And in that demo, in that extraction, we can transfer funds from Asset Hub on Kusama to Asset Hub on Polkadot. This demo can be achieved via the palette bridge assets with dedicated extrinsic. But I need to point out, I need to say that this palette bridge assets is only demo palette, is only POC palette. It will not be used in production. The final asset transfer over the real Kusama to Polkadot bridge will be done directly via the palette XCM with the usage of reserve-based asset transfer. Now let's talk about the infrastructure that we need to play with that transferring assets from Kusama Asset Hub to Polkadot Asset Hub. So at first we have the source ecosystem, Kusama, and within that ecosystem we have Asset Hub and also Bridge Hub. We also need a destination ecosystem, Polkadot ecosystem. And within the Polkadot ecosystem, we have destination Bridge Hub and destination Asset Hub of our transfer asset over a bridge. And also we need a relayer that sends messages between Rokoko Bridge Hub and Wokoko Bridge Hub. Because we talk about Rokoko to Wokoko, Rokoko mirroring Kusama and Wokoko mirroring Polkadot. So that asset transfer with that demo palette, demo extrinsic, is similar to reserve-based asset transfer. It just simplifies some stuff. The requirement for playing with the demo is that we need to have wrapped assets created on the destination asset hub. And you need to remember that you need to send at least minimum balance over the bridge, because in other case, your try will fail. So how does it work? So at first, we are on the source asset hub, and we move our assets as a reserve to the sovereign account of the destination chain. So on the asset hub of Kusama, we move our funds as a reserve to the sovereign account of the Polkadot asset hub. Then we have a message sent over the bridge to the destination asset hub. The instruction set sent over the bridge to the destination chain. And then on the destination chain, we have wrapped assets issued to the destination account. Now let's talk about the first part of the bridge. So we will talk about the source ecosystem. We will talk about Rococo mirror in Kusama. We will talk about source asset hub on Rococo. We will talk about source bridge hub on Rococo. So what's going on there? So at first, user submits an extrinsic with that demo palette, and behind that extrinsic, we have transfer reserve asset instructions sent to the asset hub. So on the asset hub, we have that instruction executed, and that instruction moves assets as a reserve to the sovereign account. And then we send a message to the bridge hub from source asset hub to the source bridge hub, and we tell the bridge hub to export some instruction set to the destination chain, to the destination ecosystem. So bridge hub proceeds that export message instruction, and at the end, bridge hub puts some instruction, some message into the outbound line, and in that message we have instructions to deposit asset on the destination account. We talked about how to play with the demo asset transfer, but how to send any general message over the bridge. So to do that, we need from any other parachain just send a message to the bridge hub, and in that message we need to send export message instruction. Inside that instruction, we need to specify to which destination we want to export our instruction set, and in that case, we export instruction set to the parachain 1000 within the Rococo global consensus system. And then we need to specify the whole instruction set to be sent over the bridge. What are the key components of that part? So at first, we need to have proper XCM message that is sent from the source chain to the source bridge hub, from source asset hub to source bridge hub. In that demo case, we need to, of course, have proper XCM configuration for the source chain, and we will check that configuration later. We need to have opened HRP channels between source chain and source bridge hub. We need to have palette bridge message deployed on source bridge hub, and that palette will put messages into outbound lane. We need to have proper configuration, runtime configuration for the source bridge hub, and of course, we need to have a relayer that is listening to messages on source bridge hub and is able to send messages to the destination chain. Now let's talk how inbound messages get proceeded on the destination chain. And in that case, we will talk about Rococo mirror in Kusama, and the destination chain will be the Rococo asset hub. So what's going on with the relayed message? So our relayer relays the message at first to the bridge hub. That message contains instructions for the asset hub, but on the bridge hub, at first we have light client verification if that message is finalized within the source ecosystem, source chain, and then the bridge hub forwards the instruction set to the destination chain, which in that case is the asset hub. And on the asset hub, we execute instructions to deposit some funds on the destination account. So now we have wrapped assets issued on the destination account. What are the key components of that part? So at first, we need to have palette bridge message deployed on the destination bridge hub. And within that palette, relayer will trigger receive messages proof extrinsic. That extrinsic will put incoming messages into inbound lane. Also, we will have at the destination bridge hub light client verification of incoming messages if they are finalized. Of course, we need to have proper runtime configuration for the bridge hub. We need to have proper runtime configuration for the destination chain, which is asset hub in that case. And we need to have opened HRMP channels between the destination bridge hub and the destination chain. About the configuration, we will talk during the code walkthrough. Now, it is time for the demo. So at first, I need to open some tabs. So I will need to have WalkMint, that is Asset Hub on Wococo. I will need to have Wococo Bridge Hub. I will need to have Rococo Bridge Hub. And I will need to have Rockmine. Okay, now let's check if we have funds. We have funds. So before playing with that demo that is posted on the Polkadot forum, now let's check the current state of the account to which we will transfer assets over the bridge. For that, I will query the state of the foreign asset palette, and we will check how many tokens of the some asset is assigned to my testing account. Okay, so we have 569 millions of units for now assigned to my testing account. So now it's time to play with the demo. For that, I have prepared the encoded extrinsic to submit, and in that extrinsic we use bridge transfer palette, that demo palette, and we use transfer asset via bridge extrinsic. And the first argument of that extrinsic is the asset that we want to transfer over the bridge. In that case, it is built-in currency of the relay chain because of parents one specified here, because we are on the asset hub on Rococo. And also we need to specify to which location we are going to send those funds. So we just specify that we want to send those funds to the Wococo parachain 1000 within Wococo, which is asset hub, and some account on that asset hub. So let's submit the transaction. Oh, I need to put a password. Now let's wait till the transaction will be proceeded on the source asset hub. It can take some time. Okay, so the transaction has been proceeded on the source asset hub. Let's check the events. So we can see that we have assets moved as a reserved on the source asset hub, and also we can see information from the bridge transfer palette that transfer over bridge was initiated. Now, on the Rococo bridge hub, on the source bridge hub, we can see that message was accepted, and that message is going to be sent over the lane. So it means that the message sent from Rococo asset hub to the bridge hub is put to the outbound message lane and waits to be relayed to the destination bridge hub. Okay, the message gets relayed because we can see the event that Wococo bridge hub, destination bridge hub, received a message from somewhere, And on the destination asset hub, we can see that foreign assets were issued to our specifying account. The amount is correct. We can see that the foreign assets points directly to the asset that we sent over the bridge. Let's check also the current state for the foreign asset palette for our account. Kusama. And for now, it is 669 units of a token, which is correct number. After sending a message from Rococo to Rococo, we should also expect additional event on the source bridge hub, on Rococo bridge hub, and that event is message delivered. That event says us that the message was delivered by the relayer to the destination chain, and it gets proceeded included in the destination chain. So that's the confirmation that the message is delivered, and with that, the relayer can claim the reward. So that's all about the demo. Now let's have code walkthrough. At first, we will talk about the demo palette bridge transfer. And with that demo, I trigger transfer asset via bridge extrinsic. In that extrinsic, we just fetched bridge configuration from the storage, do some initial checks, and then triggered do reserve and send in transaction function. In that function, at first, we calculate the reserve account on our source chain, source asset hub. Then we check some stuff within the bridge configuration that we already fetched. Then we calculate our sovereign account on the destination chain. So on the destination chain, we want to know the sovereign account of the chain that we are already. So in that demo, in our case, we want to calculate the sovereign account of the Rococo asset hub on the Rococo asset hub. Then we prepare some XCM context. Then we use asset transactor to transfer assets as a reserved to the reserve account. Of course, we need to deposit some events that the asset was deposited. Then we need to prepare some information for the destination chain, what to do with that. And then we have the whole instruction set preparation. So the first part is about buying execution. That stuff is defined within the bridge config in maybe by execution attribute. And in our case, it is unpaid execution because we use only system parachains. We use asset hubs and bridge hub. That is why we specify an unpaid execution. But in a case that we will need to pay for the execution, we need to send over the bridge some instruction. So to at first withdraw assets to pay for the execution and an instruction to buy execution on the destination chain. After specifying the instruction set for playing with execution costs, paying for the execution, we need to specify the main instructions to be executed on the destination chain for that asset transfer. And those instructions are reserve asset deposited and deposit assets. And after preparing those instructions, if we need to pay for the execution on the destination chain, after the execution, we want to refund unspent funds to our sovereign account on the destination chain that we calculated previously. And then we trigger initiate bridge transfer function. In that initiate bridge transfer function, we just put some stuff to the XCM messages, but the main part is here. So we tell the bridge XCM sender that is specified in the source chain runtime configuration. We will have a look at it. So we tell that bridge XCM sender to send our message over the bridge, and then we deposit event that transfer was initiated. We saw that event during my demo. Okay, so now let's talk about the bridge XCM sender that I mentioned previously. So the bridge XCM sender, in that case, from Asset Hub to Asset Hub over the bridge, we can use unpaid remote exporter. We can have unpaid execution because we use only system parachains. In that exporter, we do some initial preparation, stuff like that. And also we fetch another one, the bridge configuration for that location. After fetching that bridge configuration, we check in that unpaid remote exporter if we don't need to pay for the transaction. In other case, we erase the error. Then we prepare the messages to be sent from the source chain to source bridge hub, from Rococo Asset Hub to Rococo Bridge Hub. And in that messages, we have unpaid execution on the Rococo Bridge Hub. And the second message is export message instruction. And that instruction contains to which network we are going to export some message stuff, some message set, to which location we want to export that our instruction set, and also our instruction set. So that message with unpaid execution and export message is sent from Rococo Asset Hub to Rococo Bridge Hub. And it is sent here. Okay, so we covered it. Now we have pallet bridge messages to cover. And the first instruction, the entry point for transferring some messages over the bridge, for sending some messages over the bridge. So as I previously said, that function is called by other runtime pallets. And in that function, at first we check if the outbound lane is active. Then we check if the message is valid at first on the source chain. So on the bridge hub, on the source bridge hub, we check if that message will be marked as valid on the destination chain. Then we do some checks within the lane. Because as I previously said, any runtime developer can set some rules for the lane, like, for example, max message length or any other size. And this is the time for that kind of verification. Then we just prepare the payload, encode the payload to be sent over the bridge, the message to be sent over the bridge. And then we put the message into the message lane, and we get the nonce, the identifier, unique identifier of the message. and we deposit some events. Message accepted, and that event we saw during my demo on the Rococo Bridge Hub. Then we have receive messages proof. So that extrinsic is called by the relayer on the destination bridge hub with the pallet bridge messages. And in that extrinsic, we do some initial checks. We check some declared weight for the extrinsic. Then we decode messages and verify them. This is here we have the whole on-chain message verification if those messages are finalized within the source ecosystem. Some additional stuff. Then we measure weights for every message that is relayed, and if we have enough weight to be spent, we just dispatch the message with the help of message dispatch trait implementation that we'll have a look at later. And then we just release some unspent weight, stuff like that. We pay the reward to the relayer, and then deposit event messages received. That event we saw on the Rococo Bridge Hub, Polkadot Bridge Hub. Another extrinsic, receive messages delivery proof. So that extrinsic is called by the relayer on the source bridge hub to confirm that outbound messages are delivered to the destination chain. And in that extrinsic, we have some verification if that action occurred on the destination chain. We also mark messages as delivered. Of course, we emit an event messages delivered event that we saw almost after my demo on the Rococo Bridge Hub. We pay the reward to the relayer, and basically that's it. Then we need to talk about whole runtime configuration for the bridge hub, destination bridge hub. So at first we have light client for relay chain headers. I mean, we have pallet bridge grandpa for Rococo relay chain. We specify that within that pallet we are going to verify finality on Rococo relay chain. That's mainly it. We also have a pallet for verifying if Rococo bridge hub, source bridge hub blocks, headers are finalized within the Rococo relay chain, source relay chain. And in that pallet configuration, we need to specify which pallet is used to check finalization of relay chain headers. We need to also specify which pallet on the Rococo relay chain, on the source relay chain, is used to play with parachains headers. And that's basically it. We also have a pallet bridge relayers. In that pallet, we have two traits that we are interested in. The first trait tells the way how the relayer is awarded, and for that we use palette balances. And another trait, stake and slash. For that, I need to provide more overview. So a relayer, before relaying messages, needs to stake some amount of funds just to start relaying. And once a relayer starts to behave in a bad way, starts cheating, the bad relayer gets slashed. So that is the specification for that. And we also have a dispatch blob, message dispatch, that I mentioned during talking about dispatching messages in the palette bridge messages. So this is the implementation of that message dispatch. And in that implementation, we just fetch our current universal, our current global. We also decode the message that is sent over the bridge. We compare if the consensus system is proper for that message. And then we send that message, we forward that message to the destination chain. In that case, it is the destination asset hub, Wococo asset hub. Now let's talk about the destination asset hub runtime. And on the destination asset hub runtime, at first, we need to have two instances of the asset palette. The first instance used for regular assets, trust-backed assets, typical configuration for that instance. But for the foreign asset palette, foreign asset instance, as I previously said, asset ID is set to be a multi-location of the original asset, and foreign assets can be created only by axiom calls. Besides the whole foreign asset palette configuration, we need to know how to translate the original multi-location of the message sender on the destination chain. So in our case, we send a message from Rococo Asset Hub to Wococo Asset Hub. And we need to know on Wococo Asset Hub how to translate the original message sender from Rococo Asset Hub. And for that, we need to specify location to account ID conversion mechanism. And we used for that global consensus parachain converts for. This is some implementation that can be found in the Polkadot repository in XCM builder part. And in that location conversion mechanism, we just check our universal location. We just unpack some information from the original sender multi-location, and then we check in that specific implementation if the message was sent from some parachain. That's it. And in that case, we just calculate the account ID. So we just calculate the sovereign account ID for that original sender on our destination chain. And that's all of my presentation. That's all from my session. Do we have any questions? So While talking about the fees, because for now I'm trying to answer the question about fees between Polkadot and Ethereum, everything depends on the implementation of the Ethereum to Polkadot bridge. Okay, Roger, so a link to that forum post. I can just present it now that anyone can scan it and play with that that demo by himself. Okay, so we can check the deliver proof message by doing like client verification of the source chain on the destination chain. The whole stuff is done by the cryptography that is included in like client message verification. Yeah, this is, we can say that is kind of checking some hash. If that bridge will be built, I mean Polkadot to Ethereum bridge, you should be able to transfer your tokens to your Ethereum account on Ethereum, but on Ethereum you will have wrapped tokens of that native currency. Okay, so I think that there is no more questions. Thank you so much for your attention. I hope you enjoyed the session, and I wish you a great weekend. See you next time.